People of shock waves, Jakob Ackeret, the Swiss pioneer who mapped supersonic flight. In the early 1920s, aviation was still in its infancy. Aircraft flew slowly, close to the ground. But a few visionary scientists were asking a radical question. What happens when an airplane approaches the speed of sound? The mathematical tools didn't exist. The wind tunnels hadn't been built. The very concept of measuring speed relative to sound velocity lacked a name. One Swiss engineer would provide all three, laying the theoretical foundation for supersonic aviation. This is the story of Jakob Ackeret, the man who gave us the Mach number and taught us how wings behave at supersonic speeds. Jakob Ackeret was born in 1898 in Zurich, Switzerland, the son of Jakob Ackeret, a master locksmith. After completing his education at the Industrieschule Zurich, young Ackeret enrolled at the Eidgenössische Technische Hochschule, ETH Zurich, one of Europe's most prestigious technical universities. From 1916 to 1920, Ackeret studied mechanical engineering, excelling in both theory and practice. His brilliance caught the attention of Professor Aurel Stadler, one of the most eminent representatives of mechanical engineering of his time, a pioneer in turbine design. Ackeret became Stadler's assistant, but Stadler recognized a young engineer needed exposure to a new science, aerodynamics. On Stadler's recommendation, Ackeret went to the University of Göttingen to study under Professor Ludwig Prandtl at the Aerodynamische Versuchsanstalt, the AVA. There he would learn the aerodynamics of aircraft from the master of fluid mechanics himself. Between 1921 and 1927, working at Prandtl's Institute, Ackeret tackled the impossible. He worked out the essential theoretical fundamentals of supersonic flight. In 1925, Ackeret published his masterwork, a linearized wing theory for thin, sharp-edged supersonic airfoils. The mathematics were elegant but profound. Ackeret showed that supersonic flow behaved fundamentally differently from subsonic flow. At supersonic speeds, disturbances couldn't propagate upstream. Information traveled only along shockwave angles. His equations predicted lift, drag, and pressure distributions on wings moving faster than sound. This became known as Ackeret theory, a cornerstone of supersonic aerodynamics. In 1932, the British physicist Geoffrey I. Taylor restated Ackeret's theory for the benefit of English-speaking readers, spreading these revolutionary concepts internationally. Between 1925 and 1926, Ackeret directed the extension of Prandtl's Institute, financed by the German government. The expanded facility became the famous Kaiser Wilhelm Institute für Strömungsforschung. These new installations were used to study problems in gas dynamics and cavitation, and to test new aerodynamic theories of flight at high speeds in practice. In 1927, Ackeret returned to Switzerland, becoming head of the hydraulic laboratory at the machine factory Eschweiss AG in Zurich. From 1927 to 1931, he established testing procedures for hydraulic machines as well as for gas and steam turbines, applying his fluid dynamics expertise to industrial problems. In 1928, Ackeret qualified as a university lecturer at ETH Zurich with a paper entitled Über Luftkräfte größerer Geschwindigkeit und insbesondere bei ebenen Strömungen, on air forces at very high velocities, particularly for two-dimensional flows. In this wake, Ackeret coined the term Mach number, the ratio of flow velocity to the speed of sound. Named after Austrian physicist Ernst Mach, who had first photographed shock waves, this dimensionless number became the fundamental parameter for characterizing compressible flow. Today, every supersonic vehicle is described by its Mach number. Ackeret also investigated the aerodynamic lift of rotating cylinders, known as the Magnus effect, which led to the development of the Flettner rotor in 1925 for possible driving and modernizing of sailing ships. Between 1925 and 1927, he studied the removal of boundary layers by suction to increase lift or to reduce the length of diffusers, crucial for both aircraft and turbines. In 1931, Ackeret became Privatdozent at ETH Zurich. 3 years later, in 1934, he was appointed full professor of aerodynamics and director of the newly founded Institute für Aerodynamik, the IFA. Ackeret's vision was ambitious, construct the first closed-loop supersonic wind tunnel. Between 1933 and 1934, built in cooperation with Brown Boveri & Company, BBC, in Baden and Eschweiss AG in Zurich, this revolutionary facility was installed at ETH's new Maschinenlaboratorium. The closed-loop design recirculated working gas, making continuous supersonic testing practical and economical. The tunnel could generate sustained supersonic flows, allowing systematic study of shock waves, supersonic airfoil behavior, and compressibility effects. A similar wind tunnel was built under his direction at the Italian Research Center at Guidonia. Ackeret's transfer of scientific know-how of modern aerodynamics to construction and economic operation of steam and gas turbines was particularly successful and acknowledged worldwide. In 1938, Ackeret treated the problem of cavitation, the formation of vapor bubbles in liquid flows when local pressure drops below vapor pressure. This research was essential for the trouble-free operation of steam turbines, preventing blade erosion and catastrophic failures. From 1934 to 1961, Ackeret served as editor of the bulletin Mitteilungen AUSDM Institute for Aerodynamik ETZ, where his most important results were also published, documenting nearly 3 decades of innovation in high-speed fluid mechanics. Jakob Ackeret died in 1981, but his influence resonates through every supersonic aircraft, every gas turbine, every wind tunnel test. He provided the theoretical framework for supersonic flight before anyone flew faster than sound. He built the experimental tools to validate those theories. He coined the term Mach number that defines high-speed flow. From locksmith's son to professor, Ackeret bridged theory and application, understanding that shock waves and wind tunnels and turbines obeyed the same laws, and he revealed those laws to humanity. Jakob Ackeret, the Swiss pioneer who mapped the supersonic realm,